Hi, I'm Becky from Grundfos, and today I'm going to take you through the new SCALA2 checklist. It was a list that we developed based on good plumbing practice, either relative to the plumbing code or for the product itself. We're going to go through pre-installation considerations, the mechanical installation, commissioning the pump, and then some further considerations that you need to be aware of after you've boosted the pressure inside the home. This checklist will be available inside the box or at the link provided in the description. So let's get into it. So before we get started, the most important thing to understand with residential pressure boosting is that no booster pump can create more volume. Your system has to have enough volume to elevate pressure and drive all of the plumbing fixtures inside the home. Now you can get a bucket and run the test, but ensure that you have an adequately sized service main coming into the home and that your meter is sufficient to provide enough water for the booster. So the next thing we want to think about is the electrical connections. Now the SCALA comes in either 115 or 230 volt with a standard plug-in connection. But because it is a variable frequency drive, the AC to DC current in our control valve sometimes has a bit of residual current leakage, and it's usually enough to pop most circuit breakers. So if you are required by code to plug this pump into a ground fault circuit interrupter, you must use a Type B or CD, or you can have an electrician cut the wire and hardwire it into a box with a remote disconnect. But please make sure that you are contacting a licensed professional before attempting any of this. Okay, so the next thing we're going to do is we're going to verify inlet and static pressure, and the best way to do that is with a red line gauge. You can attach this to an external fixture and let it run overnight. The gauge will actually move that needle, so if you have high pressure spikes in the middle of the night, the gauge will tell you, and you might need to put a pressure reducing valve on the system. The other thing is to test it at the boiler drain on the water heater. Make the attachment, and that's how you can find out what your internal static pressure is. We need that information because that's how we're going to establish our set point for the boost. So now we know our static pressure inside the home. This is important because it gives us a calculation on how we can set the highest distribution point for the SCALA2. It's important to note it only has a 51 psi differential between suction and discharge. The pump itself is capable of creating up to 80 psi, which is the maximum allowed by code. But to achieve that 80 psi, you have to bring at least 30 pounds of positive inlet pressure into the pump. If you don't have 30, you won't be able to achieve 80. So it's important to establish your baselines and also to set some realistic expectations of what the pump will deliver once it's installed. The other thing you need to be aware of is water conditioning equipment. Now the SCALA2 is a very robust pump, but RO water can be extremely aggressive. As you pull material out of the water, it is very aggressive and it tries to attach itself to minerals inside your piping and inside your pump. So for this reason, we do not recommend you running RO water through the SCALA unit. You can place the pump prior to the conditioning equipment and pressurize before, but never downstream. The next thing you want to think about is where is this pump going to live in the mechanical room? We want a clean, flat, horizontal surface, usually the floor. If you need to elevate it, you can, but make sure that the pump is horizontal and that it is free of obstructions all around it. Once you've installed a booster pump, you need to make certain that there is thermal expansion protection on the plumbing system. The booster pump will have a check valve in it, and when you introduce a check valve into your plumbing system, by code you're required to protect for thermal expansion. Water heats, it takes up more space. It can increase the static pressure inside your home, and it can damage fixtures if it's not properly addressed. So we're going to get more into the thermal expansion later, but understand that anytime you boost into a system, you will have to protect for thermal expansion. One of the other special features about the SCALA2 is that it's able to pull suction lift, meaning it can take the water out of a ground source type tank for rainwater harvesting or other kind of cistern applications, But since most residential applications are designed having positive inlet pressure, even though that pressure is low, we disengage the lower check assembly so that it isn't clattering, because the incoming water pressure will push that check valve and make noise. So we disengage the lower check. If you want to use the SCALA2 to pull a suction lift, simply go to the drain port, take off the cap, and remove the little white pin that disengages the lower check. Now, the lower check is active and it will hold prime in a suction lift application. Now we're going to move to the mechanical portion of the installation. You want to have at least 12 to 15 inches of clear space in front of and behind the SCALA unit for maintenance and to make sure that our plumbing stays straight. So the next thing we want to do is make sure that we have mounted our SCALA securely to the floor. Now you can use vibration pads in this installation, and we recommend that you do, because anything you can do that can control this vibration will reduce the amount of sound that's being transmitted through the piping and could potentially cause notice by the homeowner. So we want to control that as much as possible. Mount it directly to the floor though, because when the pump comes on, it creates a lot of thrust. And that thrust, if you're hard piping, can damage the connection piece if the pump is not secure. So now we're on the topic of connections. We recommend the use of a 1-inch by 24-inch full port stainless steel connector. Although some people do choose to hard pipe this, flex connectors are the best option for you because they reduce the amount of sound due to vibration in the system. And when it comes to your connections, you want to make sure that there is at least 10 inches of straight pipe coming into the suction side of your SCALA. On a pressurized situation, we want a nice, smooth laminar flow. If you put any restrictions or fittings on the suction side, you can cause the pump to overwork itself and potentially overheat. Another reason why we recommend the 1-inch by 24 flex connectors is that we need at least 24 inches of 1 inch before we reduce. If you were to reduce immediately off the pump, you're creating a lot of back pressure inside the system, and it can cause the pump to overheat. It's a water lubricated pump, so we need to be able to get a nice full flow through the pump to move the heat away from the system. So 2 feet is recommended before you reduce. And please do not put any fittings on the suction or the discharge. This can potentially lead to cavitation or pump damage. When making the connection for your stainless connectors, you want to make sure that you're using a thread sealant that's approved for PVC threads. Teflon tape is great, but be sure that you don't overwrap it. We need to be able to feel those threads through the Teflon tape to ensure that we're getting a nice tight connection at the fitting. If you're using a flex connector that has an O-ring seal, you don't need a thread sealant. The O-ring will be sufficient. And if you're using a paste, don't use a hard setting thread sealant because it could potentially create a leak path. Aside from the PVC threads that connect to your flex connectors, we also have those unions where the swivel takes place. It is important, do not put a wrench on those union connections. It's hand tighten only. Okay? There's an O-ring that can be damaged, so you want to tighten the union connections at the swivel by hand and also the priming port. All of these have an O-ring seal. They don't require a tremendous amount of torque, so don't put a wrench on it, even though you may feel tempted to do so. And just like any other pump, it needs to be primed, which means we have to fill the pump with water, right? If you're working on a suction lift application, you may have to physically remove the priming port cap and pour about a half a gallon of water inside the pump to properly prime it. If you're in a positive pressure situation, however, you can simply turn on the water and open the priming cap ever so slightly to allow the air to escape. Once you start to see the water reach the cap level, go ahead and tighten it back down and your pump is primed. Now we move to the commissioning part of our checklist. You have your pump installed, You know what your incoming water pressure is, and you have all of your connections correct. We're going to go out into the home and we're going to start the water flowing, see what kind of pressure we can achieve within the system. The homeowner's happy with it. We're going to come back to the pump and finish the commissioning. Now that we know where our discharge pressure is going to be, we want to set and commission the internal diaphragm tank in the pump. So we're going to shut off the water supply main, stop the pump, and then depressurize the system by simply opening a tap. The internal diaphragm tank will always read system pressure unless you isolate it from the system by stopping it and taking the pressure off by opening a tap. Now we've stopped the pump and we're going to set the internal pressure of the diaphragm tank. Because this is a VFD drive, we need to set that tank at 70% of our discharge pressure. Okay? On the pump, there is a QR code. If you scan that code, it will lead you directly to the quick sizing guide that will show you all of the PSI increments on the pump and the corresponding internal pressure for the diaphragm tank. You'll need a small compressor and the ability to put that precharge into the tank. Now that we have our internal diaphragm tank pressure set, we can open up the mains, turn the pump back on, and then purge any air that may have gotten into the system while we were commissioning the tank. When you shut the water off, the pump will surge as it fills the internal diaphragm tank, and then it will come to a stop nearly immediately. If the pump doesn't stop when water is been shut off, then there is something misbalanced between the discharge pressure and the internal diaphragm tank. If you're stopping immediately, you've got it right and you're ready to go. And finally, now that you've got your pump commissioned, the Scala has a very unique lockout feature. If you press and hold the up and down arrows for 3 seconds simultaneously, it locks out the control panel. This can help the inadvertent adjustment that somebody might make if they walk in and say, maybe I can turn this up or down a little bit. We don't want them to do that because that will put the pump out of balance. So just lock it out. It's best bet. So now we've successfully installed the SCALA2. Congratulations. But there are a few things that you do also need to keep in mind. The internal diaphragm tank, the one you've charged to 70% of your set point pressure, needs to be checked annually. Just like your tire gauges or your tires on your car, it may require additional air. So at least once a year, come back and make sure that you are holding the correct internal pressure in that tank. One other point that we highly recommend is the use of a bypass and installing a bypass in the water main system. The bypass circumvents the Scala and makes sure that there is at least some water pressure flowing into the home while you're maintaining it. The other thing you may run into is water hammer. Water hammer is created by an increase in the velocity of the water moving through the plumbing system. Your booster pump is going to increase that velocity, so it's entirely possible that you may get some banging pipes. This is very simple to correct. Aftermarket water hammer arresters are available, and you can install those on the fixtures that are causing the bang. While most of the SCALA2 installations are inside, we can also install the pump outside. It has no problem dealing with the elements. However, it will freeze if the water gets too cold. So in the season, you want to make sure that you drain the pump down and either move it inside or be sure that you've opened it up to protect the pump from freezing. We also want to make sure that it's not under direct sunlight. The cold water inside the pump can sometimes cause condensation, and that will potentially damage the electronics in the pump. So please protect it from extreme conditions, direct sunlight, extreme heat, and extreme cold. All right, so now we've come to the end of our installation and to the end of our checklist. I hope you feel much more comfortable installing the Scala, but if you ever have any questions, please don't hesitate to reach out to Grundfos. We're here to help.